In this video, we're going to create a concrete headwall parametric cell using the standard. And we're going to first focus on these particular variables, the X for the back length, the wing lengths, and the height. We're going to go ahead and add a bunch of the other stuff too, but we're going to focus on these main variables. So the first thing that we're going to do is create an empty seed file and create those variables. We're going to create our back length or our width. Mislabel the H for W. We're going to go put in the lengths for the two L's. We are going to add the thicknesses because it's used multiple times. And what we're going to do is add two angles so that we have the flexibility to flare them at different angles depending on my standard. In this particular standard, it's a standard 45 degrees on both sides, but I do have other standards that could use this for 60 degrees, for 30 degrees, or for custom. The first thing we're going to do is going to create a helper line. I usually use this as my main center point that's going to stay fixed, not going to move anywhere. I'm just going to draw a straight line. It's going to represent the back, and I'm going to put it at my origin point at 0, 0, 0. I typically just like to do this as a standard, and I'm going to make sure it doesn't move anywhere and it's fixed, so that when I apply my variable, it goes both sides. It is fixed around that point, and it expands or contracts outward based off the variable instead of being fixed to the original one-sided point. The next step I'm going to do is create the rough outline shape of the bottom of that head wall. And we're going to do the same thing. We're going to start defining some of these pieces. So I have my X, which is going to be 6 feet, and my two sides are going to be L. And it's a little bit off because the angles are different weird, so we're going to assign the angles. Now it's important to do it in the right way here. You can see as you do it, you have the ability to define the angles in different quadrants. So being that they're all even and they're equal, now you can see it's quite symmetrical. The next step I'm going to do is affix that one shape to the original line using the coincident constraint. And now that I have that here, I'm going to start creating these little boxes, these little rectangles that I'm going to use to extrude upward and downward. So this is going to be for that back end where I'm going to choose X. And the nice thing about this is if I copy it, it will also copy all of the different constraints that I have. So I used auto constraint to make sure that it's always parallel and perpendicular, which is what I want, but I also copied it so I can then quickly just create the X and move it to L. So I can do it for the two sides. So I have the back length and the two wings. So that next step I'm going to do is affix the center point by selecting that static first point to the new rectangles that I drew, where I want them to be kind of anchored to. So the first step is I chose a center for the back X because I wanted to expand that way, but I do want my coincident constraints on the wings to be at the edges. And so I'm doing it for both sides. And I'm making sure that those wings are on the inside of this shape. And as always, as you go in and add your coincident constraints or your tangent constraints or your fixed constraints and you expand things and you change some of your variables, change a lot of these variables to make sure that it works appropriately. Now what I did here is extruded that back end because that back end is going to be one kind of big rectangle, and I'm going to assign that as that W value. And the next step is I'm going to start drawing my wings. And so what I like to do is I like to draw, again, helper lines. I move to my front or my right view, and I'm using AccuDraw to lock in a completely vertical line here. And this is going to be a helper line that I'm going to use to place at the points that I want to make sure I draw along the same plane. So I'm going to copy this line and move it to the inside edge of one of the wings, or both of the wings. And I'm going to use the smart line to draw a shape, and I'm going to snap to these helper lines so I can draw this triangle piece. And then once I did that, I drew what I wanted. I don't need those helper lines anymore in this particular case, so I deleted them out. Now I want to make sure that these kind of move in and outward. So I have my bottom shape that is constrained appropriately, but these wings, the triangles, are not constrained anywhere. So I'm going to make sure that I constrain them to the height, and I'm going to constrain the lengths. And then I'm going to extrude them. Now, because my angles are on the top plane or on the flat plane, and these triangles are perpendicular to it, instead of assigning them angles, what I'm doing is just fixing them to the box that I had drawn underneath it. And I'm using the coincident 3D constraint. So remember, when you're applying all these constraints, you want to choose the static option first, or the primary shape or line or point, and then the secondary is going to be the one that you want it to move. So I can see it easier. I just change all the values to a magenta color, and I want to take a look at it in thematic or transparent or solid mode, and then test it. So change some of the angles, change some of the lengths or the widths. And to clean things up, I'm just going to change that bottom plane to construction class and turn construction off. Now the next thing I'm going to do is trace over the bottom lines for this collar. And because I'm tracing over them, I know that they're all going to be on the same plane. And so when I apply some of the constraints that I might have later on, I'm going to be fine. I typically go to top view, select all of them, and then move them. And as long as I don't move my Z value as I move them, then they should all be at the same plane. And just like with the others, I'm going to make sure that I all constrain them. Perpendicular and parallel. Auto constrain helps a lot with that. Just like we had done before, in the first step, I'm going to assign the back wall value, the wing lengths values, and the angles. Now here I'm going to do a little bit of cleanup because I'm going to extrude. I want to make sure I extrude these lines down the right way and the right lines. So I have some of these helper lines that I had drawn before. I'm just going to change them to construction class like I had done with the other large shape. And so all I have is my solids right there. And I'm going to select them just to make sure that I only have one element selected in the properties dialog. And then I'm going to use a coincident and affix the new shapes that I drew to the old shape, to the old solids. And then extrude all of them downward the thickness of the collar, which happens to be 4 inches. Again, always good to test. Change my lengths, change my angles, make sure that it behaves appropriately. Now, what I want to focus on now is that bottom shape. So now that I have my collar, it sits on a flat bottom shape. There might have been better ways to draw this, but this is just happens to be the way that I did it. A little bit more efficient ways are definite to be had. So just like with the other collar, I traced over some of these points and I'm moving it off to the side. Again, applying very similar constraints. My back wall value, my lengths, my angle. Now this is a little bit different because this is the outside perimeter, which kind of has this little lip. So I'm adding a thickness to that. And as I've kind of tested things before, I know that if I kind of change some things a little bit weird to different angles, sometimes that thickness that we had kind of seen right there becomes no longer parallel or it kind of goes out in space. So as I'm testing it, you'll see I'm going to want to choose a parallel or a perpendicular constraint along those two edges. And because I kind of trace over the bottom and they're all planar, I can now also coincidentally tie that bottom shape to the bottom underneath that collar. Now I'm going to add the thickness of that bottom plate. And then I think the last thing that we're going to want to focus on after we do some testing is a toe footing. And so for this footing, all I'm going to do is kind of just draw that one rectangle shape. Constrain it, the thickness that I want it, auto constrain the edges or the perimeter. Now I kind of drew it out in space this time. I didn't trace over anything, but you can easily just move them in three-dimensional space. Just make sure I grab one of the edges and move them to the correct plane. A lot of people may employ AccuDraw to make sure that they lock in some of their planes. And all I'm doing over here is just constraining these edges. So I'm going to make sure that if one of my lengths might be smaller or one of my angles might be a little bit weird, that this shape will always retain a rectangle shape, but it will follow this edge between those 2 points. And then I'll go ahead and extrude it. Now, one of the things that I'm missing here is that if I happen to change any of my thicknesses, or if I created a parametric constraint that is going to change the value of the bottom piece that moves up and down, this toe is not appropriately constrained. But in this example, I will never use this for a cell that will expand that bottom piece. So I don't need to constrain it. But if I wanted to, I could have constrained the surfaces to touch each other using the 3D coincident constraint. And now the last piece, once I've created this cell, most of the solid objects are there. It's how I want it to be. I'm going to add all of the typical drainage and utilities points and lines. And so I use the DU tool to create the elevation point. And it put it at 0, 0, which is the back end of that wall, but I happen to want it to move it up front and forward. So just like with the triangles that we drew earlier, I'm going to draw a helper line that's going to represent that center piece because I always want it to be at the center of the wall. And I'm going to place it to where I want it to in three-dimensional space. It happens to be the center of that point. Um, and then I'm going to make sure that I use the coincident constraint. And I'm going to apply the uh, element variable for the height, that W value. Now, it wouldn't constrain because it's not on the same plane, so I'm just going to move it to the same plane. Remember to always select the primary first and then the secondary, which happens to be the point. And we can do a little bit of test here. So I'll change the back height value and it will move up and down. I'm going to do the same thing for both the bottom point and the alignment point. And because my variables are not going to really move anything past the bottom, I don't really need to constrain them. And for the VBA to propagate them into multiple individual cells, you do need to make sure that you change all of these values that are normally reserved for construction class in DU, but in this parametric cell VBA, it needs to be primary. And the last thing I'll need to do is create my connection regions. So just drew the shape, put it in space, or use the utility to draw the shape, put it in space, and constrain it to this point. I happen to have isometric lock on, turned it off, so I didn't have any issue snapping to it. And all I did was use a simple coincident constraint in 2D. And I noticed here for my VBA, it's using a constructions class to change it after it gets placed. So I didn't have it in this file. I just went ahead and created a construction class level in the manager, and I'm going to change all of these pieces to construction class. And as always, test. And it's ready for the VBA and all of your different variations.